Welcome to part two. Let's continue where we left off. So we were talking about recursion and iteration, right? Recursive and iterative. So we are done with that example. So what I would do now is I will open, um, let me see. Okay. I'll open this version, right? This diagram, because I had previously done like another version and then I realized, okay, I didn't model it the right way. So now I've done a different model, which is far much better than the previous one. So this is how recursion works, right? So let's see how we get to that point. Let's start with the second problem, right? So what I would do is I will close this project. So let me say close solution and then create a new project and then select that template and then next. And then, yeah, this should be fine. And then click create, right? So there's our project, we have it there. So let's look at our problem, right? We have this problem that we want to solve. So this is the problem we want to solve. So I'm going to write it down. So the thing we need to understand is how do we get to that answer, right? Okay, first things first, let's find out the general term. How do we, not necessarily general term, but how do we how did they get these values, right? Like how is it all of a sudden 16, now it's 25? How did they get those values? If you remember sequences and or series sequences and series, right, in metric, you'd find sort of like a general term of how everything is done, right? So how do you use to model those problems? You just count from one. So you do this, right? Each value you'd give it its position, right? That one is a position one, four is a position two, nine is a position three, and so forth, right? And then you try to use the position to find out for a formula so that we know how do we get to that answer. So you see the first one, right, which is one. One still remains as one. That's not really helpful. We cannot tell how we got to the answer. But then from term two, the second term going upwards, we can sort of like kind of find the answer of how we got there, right? If you look at two, right, how did two change to four? What must I do to two in order to get four? I must multiply two by its value, by itself. So two times two gives me four. And then three, how do I miraculously get to nine? I have to multiply three by itself, which is three times three, which gives me nine. And then four, how do I get to 16? I have to multiply four by itself, so that would be 4 times 4, which gives me 16, and so forth, right? And you can look at the series, it only ends at 25. That's the most important thing you should know. It ends at 25. So we have this series. We now know, oh, okay, at each term. So basically my formula is n squared, which is n to the power of 2, n squared, right? So the current term, if I'm looking for the second term, that would be 2n. That means n is 2. So that's 2 squared, which is 4. And then there's the 4 right there. So I already know my formula is correct. You'd have tested it with counterexamples or whatever, tested it as much as you can to fully conclude that this is the right general term. So we now know, oh, that's the general term, right? That's how numbers are generated. So now how do we find the answer for this question? We know that at each position, that number times the next term. And then if you look at it, right, how how are we going about this thing, right? So let's look at it in terms of the terms, right? In terms of the single digits, not these answers themselves, right? Because these answers, they have a formula to get there, right? Which is n squared. So how do we go about doing it? And remember what I said, let's look at it in terms, let's look at it first in terms of recursive, right? Recursion. So recursive, I know that I always start at the upper bound, right? Which is like the last term. So basically, we're going to reverse this sequence. So we know it's n squared, so let's reverse the sequence. So it's going to be 25 times 16 times 9 times 4 times 1, right? We've reversed the sequence. So we're good to go. But then remember, each number, it has a term, right? This is a fourth term, third term, second term, first term, right? So what we're going to do is we're not necessarily going to pay to this attention to these numbers for now. We'll pay attention to these numbers, right? So obviously I need to multiply, right? I need to multiply the terms, right? Each term I need to multiply it by the next term. But then before I multiply, we both know this needs to change to 25, right? So this should be n squared, right? I need to times it by itself. We'll get to that. The first thing that the first part I want you to grasp is this part. How did I get from how did I go from 5 to 4? So how did I get to 4? It's simple. I just subtracted 1. And how did I go from 1 to 4 to 3? I just subtracted 1. So basically it means that if n is 5, right, times what's the next term? It's n minus 1, which is exactly the same as our previous example, right? So it's this, we can see it, right? We can definitely see it. But then this is not correct, right? We are almost there. We are like close. We're almost there. There's a very small detail that we're missing. We just need to make this n squared, right? So this should be n squared because it's 25 times 16 times 9 and so forth. We are not multiplying it by the actual term number. We are not using the term numbers. Those term numbers, I just use them so that we can see where this minus 1 is coming from because it was the fifth term and then it became the fourth term. You could also do it with this approach, this one. To be honest, there's like, yeah, I'm thinking about it. You could also do it with that approach. But then the problem is, how will you know when to stop? That's why it's easier to start at the end and say, okay, the number of terms that I have is 5. So I know, oh, okay, it's 5, and I don't have to keep a track of a counter. You see, it becomes very complicated if you start from the beginning. You'd have to also keep track of what current index you're at or what current term you are calculating, which becomes a problem. So, okay, you technically you could, but then it's a very unusual approach. But I'll show you. I'll show you two ways to solve this one problem. So we have n squared times n minus 1, but then n is still incorrect. It's not n, right? It's not 4. It's n squared again. But then before I calculate the squared, I need to subtract the 1 from 5 first. So I need to get 4. So that means it's this whole thing, right? It's this whole thing to the power of 2. So it's n minus 1 squared, right? That's the actual formula. So this is generally what we're going to have, but I also don't like this. I didn't have to add this part because now if I add that part, it becomes we won't get the actual formula. It's going to become wrong. Let me show you why. So let's look at our diagram, right? This is our image. So the way it works, right? It's n squared, right? Let's say, remember we usually start from the bottom, but from the end, right? Which is like the last term. Then we go vice versa. We go the other way. So we start from the end and then we go to the beginning, right? from the last, we start from the last term and then we go to the first term. It's typically easier to picture it in that way compared to, get what I'm saying, doing it the other way. You still can't do it the other way. I will show you the other way. So there's many ways, there's two ways to go about it. The normal way, which is the way it was stated, like one, and then you times it by that way, we can still also do it. But I'll show you that way later. Let's start with this. So we have 5 times 5, right? How do we get there? We got there because it's this. What is 25? It's just 5 times 5, right? That's literally what I'm doing right now. So let me write it down here so that you can see. So we started 5 times 5, which is just 25, right? Times, we need to, what is n? What is the current term? What is n? In this case, it's 5, right? So if I say times n minus 1, right? What is n? It's 5, right? So 5 minus 1 is just 4, right? So it's just 4. But then I can't just say, if you remember the previous video, that's why I said you should watch the videos in order to understand the next video. And you need to watch it from start to finish. So we have 5 times 5 times 4, right? Because n minus 1, n is 5, so it's going to be 5 minus 1, which is just going to be 4. Or you can just leave it like that as is, as 5 times 1. So if you leave it here, it becomes a problem. If you remember the first video, if you watch the first video, you would understand where the problem is, or what am I trying to get to? Like the conclusion that I'm trying to reach. The conclusion that I'm trying to reach is that if you notice here, if I leave it like this, remember we need to, at the end of the day, we need to return a recursive call, right? If I leave it like that, at the end of the day, it's just going to calculate the first two terms and stop, of which is still going to be incorrect. But then, yeah, we don't want it to just calculate the first two terms. If I leave it like this, it's just going to be 25 times 4, which is 100, which is incorrect. So I need to find a clever way to continue calculating. How do I do that? Well, there's this thing called recursion where a function calls itself. So I'm going to call my function product, right? So I'm going to do this. So that function called product, it takes in n as integer, right? An integer. So I'm going to call it again, but then I'm going to call it with a different value now. I'm going to call it with the value 4. So this is now good. Remember, 5 minus 1 is just going to be 4, right? So I'm going to call it with 4. I hope you guys are watching this video step by step, or else you're gonna fail dismally on this question. You won't understand where you're going wrong. Your peers are getting distinctions, hundreds everywhere. That's why I always advise watch the video from start to finish. So we have this 5 times 5 times product of 4, right? So remember remember the syntax, what it means. It's a function call. So that means in the next step, I need to call that function, but then with the value 4. But then what's the product of 4? If you know the product of 4 is just simply 4 times 4, right? Times 4 minus 1 squared, right? But then to calculate the squared, I need to call the function again. So now I need to call the function again and say product 4 minus 1 is just 3, right? So yeah, we're going to have this. So we're going to have 4 times 4 times product of 3. And then in the next step, we're going to call the function with the product function with a new integer now, a different integer. And this integer is 3. In the next step, what is the product of 3? It's 3 times 3 times 3 minus 1. 3 minus 1 squared. Remember, eventually when I get to 3 minus 1 squared, right? We'll get to that. We have to call the function to get that answer. So I need to call the function passing in this new updated value, or the next term, which is 3 minus 1, which is just going to be 2. And then what's the product of 2? It's just 2 times 2. 2 times 2 times 2 minus 1 squared, right? But then in order to get the squared, we're going to have to call the function again. So this is just going to be the product of 2 minus 1, which is just 1. And then what is the product of 1, right? What is the product of 1? So this is a bit of a tricky step. The product of 1 is just, we can still continue and say it's the product of 1 times 1 times, and then we call the product function again, minus 1 minus 1. That necessarily won't be, it won't be a, yeah, it's not an important thing for us to do. We don't have to do that. So if you look at it, right, look at the 1, product of 1. What is 1 times 1? It's just 1. So at this step, I can just say 1 times 1, and then I actually give the answer because that's the last step. How do I know? Because this is my sequence. It starts from fifth term to the first term. And then here, remember n is our term number, right? So a term number, when you with the next step, we have to find the product where where the product of the first term, which is just 1 times 1. You see, there it is. That's the 1 there. We were now there. And then now we need to work our way backwards, upwards, right? Like this, going that direction, since we started from the end. And then now we must do what we call back substitution. We go back to the previous step and substitute the answer that we finally got. We now have the product of 1. If you check here, this is going to be product of 1 is equals to this. Okay, yeah, let me phrase it that this way so that you guys can actually see it the way I want you to see it. Product of 4 is equals to this. Product of 5 is equals to this, right? So we sort of like broke down the problem into smaller into chunks, right? Into smaller pieces. So just know that this function, right, it goes to the next step. We find the answer for that function call to the next step. So now eventually we reach to product 1, right? The function we call the function when n is 1, the term is 1. That's the last step, of which the final answer is just going to be 1. And then we back substitute. We go back to the previous step. Look at this weird coincidence. We have product 1 there, and then there's the answer. And then in our previous step, we didn't know the answer for product 1 at that point. So now we now know it, which is 1. So I need to back substitute to replace this with the actual value of product 1, which is just 1. And then now look at this. It's starting to become simpler now, right? What is 2 times 2? What is 2 times 2 times 1? It's just 4, right? And then what is product 2? Look at it. There's product 2. We have the answer here. It's 4. So I know the answer for here is going to be 4, right? And then 3 times 3 times 4 is going to be what? I think it's going to be 30. 30 what? Is it 36? Let me just double check. Yeah, it's 36. And then if you look at product 3, we back substitute it again there. What's the answer? This is the answer. It's 36, right? And then what is the answer now when you multiply it by 16? It's going to be 576, right? And then look at this is starting to be we're starting to solve this problem now. What is product 4? It's 576. If you look at our previous step, we need to substitute the answer for product 4, of which we have calculated, which is 576. 576 times 25. Remember, this is just 25. 5 times 5 is 25. This should give you 14,400. And then this should be the answer. And then we are done. So this is like the step by step of how this thing is solved. So let's look at the diagram now. So there's the diagram. We started with 5 times 5. This x is times the product function. We called it again with a new value, which is just 5 minus 1, which is just 4. And then that function, right? You see the arrow is coming from that function. When we call that function and the value is 4, it's just 4 times the next term, which is times we have to call the product function again to find the next term, which is 4 minus 1, which is 3. So product of 3, of which we did it in Notepad here. We did it here. So product 3 is just 3 times 3 times the next term, which is 2, right? But 2, we need to call the product function again to find the product for 2. So product 2, as you can see, the arrow goes down there, and then it's just 2 times 2 times the next term, which is 1, product 1. And then we go to the next term, right? Product 1 is just 1 times 1. I didn't have to put this. You could put it there just for clarity so that you can sort of like have the same pattern, but you didn't have to put it there. This should suffice. So what is product 1? We know product of 1 is just 1 times 1, which is just 1. And then that's why I put this pink arrow there, that I'm saying that this 1 is going to be substituted back to as the answer for that function. So this will just be 2 times 2 times this 1 that I got here, which is just 4. And then this 4 is now the answer for this function call, which is x product 2, right? Which is product 2. So 4. So 3 times 3 times 4 is going to be 36. And then 36 is the answer for that function, which is just, so the answer for this for this step is going to be 4 times 4 times 36, because we have the answer there, it's 36, which gives us 576. And then we go up again, and then this is the last step, 5 times 5 times 576, which just gives us 14,400. And then voila, we are done with everything. So this is exactly how we're gonna do the diagrams. Okay, for you guys, it might be a little bit different because you're writing it on a piece of paper with a pen. Your lecturers should show you this diagram. It's actually like this, the diagram. But then I just messed it up on this last step. This is just 1 times 1. This last step should be 1 times 1. So we have this, and then we have solved our problem. So we now know that if you look at our image, right, we now know that the actual formula is still this, right? It's still this. But then remember, it was times the product function. So times the product function, we call the product function again, but then we pass in a new term, a different term. Because if you look at it, there it is here. There it is there. Or you can look at it from this perspective. But then I like to look at it at this perspective. It's 5 squared, right? Times the product of 4. Basically 4 times 4 product. That's why I called the function product. So this is pretty much how you're going to solve it. I hope you get it. If you don't get it, I advise you rewatch the video again until you fully get it. So for this question, I do not need what we call text boxes, because they just want the answer, the output. That's all. So the way I'm gonna phrase it, right? Remember, you see the sequence 1, they're named sequence 1 and sequence 2, right? I'm gonna create 4 buttons. That's all I'm gonna do. So there's the first button. It's gonna be there. And I'm gonna make my application a bit beautiful. Nope, sorry. I'm supposed to remove this and then go back here. And then, okay, let's start with the naming the form. So the text that's displayed, the text, it means the thing that you can visually see there. Okay, I'm gonna call it recursion because we're dealing with recursion here. Recursion or recursive and iterative, right? So as you can see, the name has changed there at the top. And then now the name, which is the name, so I'm gonna prefix it FRM, start with FRM. FRM is an abbreviation for just form, so that no matter how big my code is, I can remember, oh, FRM, this is a form. So that's the whole point behind naming things that way. So FRM, recursive, and iterative, right? So I've called it FRM, recursive, and iterative. If I go back here, you see the form name has updated, which is good. So we need to have 4 of these. So the way I'm gonna design it, I'm gonna have 2 at the top and then 2 at the bottom. I'm sure you didn't know you can do this. You can copy more than one thing at a time. How do you do that? You just select those things, right? And then you right click and then you say copy or control C. And then after copying, you just press control V or you just paste. For those who didn't know, you can do that. You can copy more than one thing at a time. So I have this weird thing that I have to make sure I always have to, my things need to align. I just have, I don't know whether you call it a disorder or whatever, but yeah, sort of like a perfectionist. They need to align, it needs to make sense. So the first one, I'm gonna call it sequence, the text, right? Pay attention to what I'm changing. I'm changing the text. So this is sequence 1 iterative, right? Perfect. And then sequence 2, okay, I need to also give it a name so that I can remember which button it is. So the name, it's gonna start with BTN, right? Which means the button, so that I remember, oh, this is a button. So BTN, so it doesn't matter how long I name it. So I'm just gonna name it BTN sequence 1 iterative. So that when I'm looking at the code, I can know which button is for which button is for which sequence. Then this is still sequence 1, but then recursive. Sequence 1, recursive. And then scroll down, btn, sequence 1, recursive. Right? You don't have to name your buttons this long, give them such long names. And then for the second set of buttons, I am going to have sequence 2. Sequence 2 iterative. There we go. And then I'm gonna have the first one. The button is going to be sequence btn sequence 2 iterative. And then the last one. Text. Let's start with text. Sequence 2 recursive. Right? And then the other one, the name is going to be btn sequence 2 recursive. Oof, we are done with that. So I'm going to do this. There's many ways you can go about doing it. I prefer to do it this way. If you put in text fields, whatever, you don't want to annoy your assistant, right? Some assistants might be having a bad day. So I advise you not to put text boxes in such simple practicals. You could, doesn't matter, doesn't really matter. But then for me personally, if I was your assistant, it's more convenient to just press a button and then you get the answer because they have the memo, right? They just compare your output with the output that they expect to come out, right? It's that simple. So yeah, let me play around with this thing. Okay, I selected the form, right? I want to change the back color. Mm, yeah, this is cool. And then for the buttons, did I select the right button? Yeah. Okay, it is the right button. Why is it showing me background? Okay, that's fine. I'm just gonna leave it like this. This should suffice. So let me click each button one at a time so that we can write the code. There we go. So our buttons are there. So there's our application. There it is. So obviously we need to start with the option statements. So don't forget to add comments. There's marks for comments. So option statements. So my option statement, option strict on, which forces the user to cast, forces the programmer to explicitly cast. If for those who tend to not understand what the word explicit means, it just means direct. I'll just use the word direct as sort of like its synonym. It means you have to directly cast. It won't do it on your behalf. You are being responsible. So we're gonna have option explicit on, which forces you to declare all variables. So you have to say private as and dim as, but then I would say explicit is mainly for global. And then if infer of the data type, you have to declare all local variables. They won't be inferred. Inferred, it means that the user, the computer or the compiler, for those who understand, the computer will not infer or think for you about what data type should it use and things like that. You would have to write everything from scratch. So we have all of this, right? I don't think we need global variables. Yeah, we actually don't. If you look at it, we don't. Yeah. So we have formula here, right? There it is. N to n squared times the product of n minus 1. And then we know our base case is when n is equals to 1. When we reach n, what's the answer of n times 1? What of product 1 is just 1 times 1, which is just 1. So if my current term is n, then I just return 1 because the product is 1. So let's start with the recursive. Let's start with button. You see button 2, right? It's the second sequence. That's the one we did. This is the second sequence. If you check the practical, this is the second sequence. So we'll start with that since we have the recursive formula for it. So I'm gonna declare a function. So okay, it doesn't. Okay, it doesn't. But then I'm just gonna say this is sequence to recursive function. So that when you look at this solution, right, I'll upload the solution. You see it you see on the YouTube description, under the description section when you're watching the video on YouTube, you should be able to see it then. So private function, remember I called it product, and then it's gonna return an integer. But then remember, it's going to return an integer, but just remember that we need to take in an integer, right? A parameter. So I'm going to take it by value. So n as integer. If you remember by ref and yeah, all those other things, you don't need all of them. You don't need those things. Why do I say so? Because in this case, I don't care what happens to this value. I don't want the change that I made to affect its original value, right? So even if it remains the same, remember when you call the function, right? N only was only changed within this function. It's not changed outside, right? N still remains the same. So that's what by value means. Or in a way, by value, it means, for example, if you let's say by value, right? Let me make a simple example. By value is you're actually getting the thing itself. So that means whatever changes you make, you don't necessarily get the thing, you just get a copy. By value just takes the copy of that thing and then you work with the copy. You don't work with the original. It's like going to what is this? The library, the one in the library at UJ, right? You go inside, you print there, you make a copy. You made a copy. So if you write and you scribble or you tear the copy into pieces, will that change the original? Will it also tear the original? Or the changes that you've made on the copy, will they affect the original copy? No, it won't, because it's two different objects, or it's two different okay, let me not use the term objects, you're not there yet. It's two different things, right? It's two different papers. I can't write on one paper and then miraculously whatever handwriting I'm writing, whatever thing I'm writing on the copy, it also appears on the first paper. This is not Hogwarts. This is not Harry Potter where you do magic. Yeah. It's not that one where we have magic wands. No, this is not Hogwarts. So that's by value. You are working with the copy. By ref or by reference, you are working with the reference, or another term for reference is address. So it's like literally visiting your friend. If you go to your friend's address, won't you find him? Won't you find the original? You will find the original. You will find him there inside the house, right? So just think of it in that way. By ref, it means you're literally finding the original, which is going to that person's address or reference to that address, you find the original. By value, imagine your friend was cloned and you are playing with the clone. The clone is not your friend. It's just a clone. It's a copy. It might mimic your friend's traits, but then it's still not the original. The point I'm trying to make is that whenever you make changes to the clone, if you punch the clone, maybe you're angry at him, you forget, oh, he's a clone. That punch won't miraculously appear on him where he is at that point at that time. Right? That's not gonna happen, right? Because it's two different people. You're working with the clone, not the original. But then if you use by ref, it means you're going to where he currently is at that address, whether it's at student center or it's campus square or the library, wherever he is, you're literally going to that address, that location, and then sorting your differences out and then punching him. Obvious that punch will land on the original person, right? Because there's no clone involved. So that's what by ref means. Just know the differences. So in this case, I don't mind working with the copy because I don't care about the original. I just don't care. All I want is to output the answer to the user. So remember that our formula, right? If you look at it here, this is our formula, n squared. Remember that there's let me see. Is it there? Just forgot. I'm not entirely sure because I've been doing a lot of languages this lately. Assembly, C++, C, and Java. Yeah, there's a lot of languages. I don't remember if this sign is the power, but then I think it's there in Visual Basic. But then to keep it simple, what's another way of multiplying the value by itself? It's just saying n times n, right? Simple as that. So I'm just gonna say return, because remember it needs to give us back that answer. So return give us back hand me back the answer. The answer of what? N times N times the recursive call of that function. But then if I don't, the problem, if you don't say -1, it's gonna keep, it's like an infinite loop. Imagine a loop that you never update. That's gonna be an issue. It's never gonna stop. So I need to update N so that eventually I get to the base case. So I need to do that. So now we need to have that's why I said watch the previous video. If you watch the previous video, you understand what's going on here. So now let's do the base case, which is when should it stop? It should stop when it finds out that N is now 1. But then what is the answer for that product of 1? What is the product of 1? Basically, what is 1 times 1? It's just 1. So I'm just going to return 1. And then the way they want you guys to write it is to use an else. You could leave it like that without the else. It's going to work perfectly fine. Typically, that's how you're going to write it. Remember, for those computer science majors, recursion is not going anywhere. You're going to meet it again in final year in what is Java. You see in Java, you just remove this and then you just write this at the bottom. It's still gonna work the same way. But I would prefer you guys write it the way your lecturers want you to write it. Or else the assistants might look at him like, some assistants are not as like intelligent as you think they are. They don't really understand code like that. So if you write it in a different way and it kind of works, they might deduct marks for implementation. They're like, "Oh, well, the way he implemented it didn't make any sense." But then to you, it makes sense because you have an advanced understanding of how code actually works. So that's why I just advise students to write the way your lecturers expect you to write it, because assistants are not your lecturers. Practicals are not marked by lecturers, right? So just write it the way lecturers write it so that it makes it easier for some assistants out there. They're just gonna look at it like, oh, it's exactly like the memo. Perfect. Then I know it's 100% correct. Some assistants, that's how they think. That's why I'm telling you to write it this way. So we have this. It should work perfectly fine, right? Let's test it out. It's always good to test it out and be sure that that thing actually works. So let me see. Recursive, yeah. So btn sequence to recursive. So I need that button. So what I'm going to do is, okay, I'll make it simpler. I'll declare a local variable. Store the answer, right? What's the answer? Dim. I'm gonna call the variable answer as integer is equals to that product function. We call the product function. We pass in the number of terms. N, remember, N is still the current term, right? But then it also kind of works like the number of terms. So obviously the maximum should be 5, right? So the maximum should be 5. So once we have the answer, I use my message box. The message box expects it expects an object. It doesn't necessarily expect a string. So I can just answer then. So that, yeah, I can leave it like this. So that's why it works without, I hadn't paid attention to that, but then you see when you declare object type in, you see object type, when you declare object type in Visual Basic, it just means any type. In simple terms, that's what it means. Any type. Because in Java, you'd say that this is the ancestor, the founding ancestor for all objects. So let's test it out and see. We're expecting 14,400, right? Yeah, we're expecting 14,400. So let's test it out and see. So there's the app, simple, elegant, perfect, right? There's 14,400. I mean, I don't know, you could actually change the style, the message box, whatever, if you to be fancy, when you're that smart, when you have all that time in the world. you're just coloring stuff, making it beautiful. Yeah. So you see the answer, 14,400. Then we know we're on the right track. If you don't believe me, let me do it with the calculator here. Because sometimes students don't believe. 1 times 1 is just 1. So I'll just leave it like that, right? Times 4, because 2 times 2 is 4. Times 3, which is 9. So I'm just going to say times 9. Times 4 times 4, which is 16. So I'm just going to say times 16 times. You see the numbers that I was writing down, we're getting them. This number here. Didn't we get this number? We did get it, that number. So times 25, because 5 times 5 is 25. You see, I am 100% sure that's the answer. So we did calculate it the right way. So we are done with recursive, right? That's recursive for you. This is how you'd write it. So this would be what we call the base case, right? Basically, like when to stop. It just tells it when to stop. And then this is the recursive call, right? Just means repeat this until the base case is met. In a way, it's like with the for loop, when you say 1, 2, that number that's next to the word 2, that's a stopping point, right? So basically, that's in this case that would be our base case. So we are done with this. It's running perfectly fine. We had no issues. Now we need to go to the iterative approach. So with the iterative, right, we don't necessarily have to start from the end, right? We don't have to start from the end. And then here I'm just gonna write, okay, let me write it like this. Sequence 2 iterative approach, so that you know which section or which pattern or which code represents what. So this is going to be a recursive approach. Please make sure you put in comments. So we have this. Let's do the iterative approach. The iterative approach is pretty straightforward, right? We start from 1, 2, 5. Remember, we can there's no way to just say started 1 increment by one. No, it's terms. Then within the for loop, we write the formula to calculate. So I'm gonna say start from come on. What am I doing? I'm gonna say for let's use T for term. For T, okay, you don't have to, but then I'm just gonna use T for term. For T as integer is equals to 1, 2, 5, right? Remember here, I don't have to put in and say step 1, right? Meaning that it should increase by 1. By default, it increments by 1. So that's why I don't put the step. The step is only necessary if you don't want to increment by the value 1. You want to increment by another value, or you want to decrement or decrease by another value. That's when the keyword step is very important. In this case, just gonna leave it like that because by default it increments by 1. So if I'm starting from 1, what's the formula here? Let's look at it. Let's think about it. If I'm starting from 1, right? If I'm starting from 1, then we're gonna have something like this, right? It's gonna be 1. Let's say t, right? Remember we're using t. T times the next t. What's the next t? How do I find the next t? The next t is just minus 1, right? Oh no, it's just plus 1, right? It's plus 1 because starting from 1, how do we go to 2? I just increase the current value, the current t by 1. But then I can't just say times t plus 1. I can't just do that because in essence, what I'm trying to say 1 times 2, which is wrong. It should be 1 times 4. How do I do that? So this is just going to be to the power of 2, right? And then times, I need to add 1 to t first, and then I take the exponent to the power of 2, right? Something like that. But then since I'm not doing, what is this, recursion, right? Like, what is this recursion? I'm doing iterative. I can neglect this part. I don't have to worry about +1 because the +1 is there in step, right? Where I removed step, that's where the +1 is. So t by default will increment by 1. I don't have to worry about that. So I can remove this part. So I know t is just t squared, right? The current t, square that value. And then that t, right? I'm gonna have a variable, right? So let's say I'm gonna call it the variable prod or product. Why not? I'm gonna call the value product, right? Remember, even though okay, let me use prod so that you guys, okay, let me use product so that you guys really understand coding. If I use product without brackets, let me show you. If I use product without these brackets, the computer knows, oh, this is a variable. And so far, there's no other variable named product. But the moment I put brackets and I pass parameter, it says, oh, this is the function. So I can reuse the same name as that function name, and there won't be any issues because I want to write variables with meaningful names. So I'm going to call it product, and then it's equals to t to the power of 2. But then if I just say it's equals to t to the power of 2, it just stores the current term, right? It's multiplying them. So how do we multiply? It's similar to the formula for adding. Remember, to add, you just say sum is equals to sum plus the current t, right? It keeps on updating that box with the label sum with the current value or the current value. But in our case, we want to multiply. So I need to say product times, and then remember that order of operation is very important. So I need to put in brackets there so that it knows, okay, this should be done on as a result of what's on the right and what's on the left. So I need to put those brackets there. Remember, odd mass, brackets of division, multiplication, addition, and subtraction. So it's going to start with the brackets, multiply, square the value, and then multiply the answer with the current value in the product variable. I need to say times because we are timesing, we are multiplying. I hope that makes sense. And then once we are done multiplying, yeah, that's pretty much it. That's the formula. So this should be the formula. So let's declare our local variable. Like I said, we're going to use only local variables. So declare product as integer. And remember, it's local, meaning that it only exists within this subroutine or this pattern. So I don't have to worry about it having it being declared in a different place and things like that. And now the question is, what value should I initialize it to? Well, this is where you need to think logically. You need to think critically here. If I set product to 0, what's going to happen? What's the rule of multiplying any number with 0? It's always going to be 0. So you're going to have an output of 0. So that's why I'm going to initialize it to 1, because 1 times any number, it's the number itself. So I can just initialize it to 1 because I know 1 won't change the number. Or if you really wanted to, you didn't know, you're not sure what value to put, you could just say it's equals to nothing. There's a keyword nothing. It's equals to nothing. Just set it to nothing, like there's nothing in there. You could do that also. You can do that. It's allowed. But in our case, right, I need to take the current value. Remember what we talked about in the previous video. If it's on the right-hand side, right, don't worry about product being repeated. If it's on the right-hand side of this equal sign or this assignment operator, what it tells the computer is go to this box with that label and take what's inside and multiply it by what's inside this box squared. right? If there's nothing inside that box, I'm saying nothing times something or times a value, which is something that we don't know. It can't calculate. So in this case, we can't use nothing, but then in some scenarios, it does help to set it to nothing if you don't know what to set it to. In this case, I just say I have to explicitly set it to 1. So now the formula is product is equals to product times the current value of t to the power of 2, right? Yeah, I think, oh, it is there. Oh yeah, the operator is there. I just forgot. Okay, option strict on disallows implicit conversions from double to integer. Okay, so as you can see, normalize looking at the comments, right? You see, if I hover this thing, right? Hover meaning going over. If I go over this thing, if you saw it when I'm sure you saw it previously to the power of 2, right? Like this, you see. Um, come on. Yeah, but yeah, it returns a double. This returns a double. And remember, you've switched option strict on. Yeah, look at it. It returns a double. The left-hand side is the base, which is t. The right-hand side is the exponent, which is 2. So t to the power of 2. You can also write it like this, but then if you write it like this, please be very careful. That's why I just decided to say t times t or n times n, because you see, you're going to face things like this and it becomes a problem. What's happening here is that you have an integer on this side, which is product. And the result of this square is a double. So you are trying to multiply an int with a double. That's going to give you a double, and then you're trying to store that double inside product. Remember what we talked about in the previous video. Boxes have a data type which tells it what type of things can go inside the box. Now you're trying to put a double inside this box, but you've told it that it can only accept integers. So what should happen is you should convert this to an int, and then your problem goes away. But then that's why I'm saying you need this approach, you really need to understand what you're doing. So I'll just advise you to write it this way: t times t, and then you put brackets there. Okay, they don't matter in this case, but then just put brackets there so it makes it easier to read. You see that they're gray, right? It shows you that they're not necessary. It even tells you parentheses can be removed. They're not necessary. But I just visual, I just want you to see it in order for you to get a simpler understanding. To picture it and be like, oh, it's product times the result of whatever's inside this bracket. Because what if the formula changes? It's now plus. You see now, you're gonna forget those brackets. So that's why I just prefer to put the brackets there so that I don't have to face those issues. And then message box, simply output the product. And then let's run it. We're expecting 14,400, right? Okay, there we go. So we did the recursive part. Now we have to test the iterative. Let's test it out. Perfect. So this is what happens when you really, really understand and you really, really plan and you calculate and you do everything. You should be able to get the values. You might have it might crash here and there, but then don't be demotivated. Test, try out a different, look at the error, try to understand the error and then fix it. So we see 14,400. So we are done with sequence 2. That's out of the picture. We are done with that. We've solved it, done. So we're done with both the iterative and recursive. Now it's time for question sequence 1. This one. Okay, let me drink some water. Hey. Okay, I'm back. So we have this sequence, right? Okay, this sequence is pretty straightforward because you see we don't have to stress about starting at the end and stuff because it already starts. It like it doesn't have if your sequence doesn't start with 1, and keeps on changing and things like that, then you don't have to worry about, you have to worry about starting at the end. In this case, it already has 100, so, and you see the 100 keeps on decreasing. So we know that this is the biggest number. As you can see, minus 50 is the smallest. This is the biggest. So it's already in an order that we'd prefer we'd prefer it to be in. So it's very convenient. So now you should be able to see a pattern to be able to quickly decipher this thing. So let's see now. How do you solve this? It's simple. We have 100, right? Let's assume 100 in this case is n. So we have 100 plus 90 plus 80, but we don't need the rest. We just need this first two to find the formula for this function, right? So 100 plus 90. If 100 is n, that means I need to say n plus, how do I get 90? I just subtract 10 from n. So I need to say n minus 10, right? And then remember, brackets are very important. So yeah, but then this, before we talk about brackets, let's move on to the next step. This is not fine, it's not complete, right? Because if I leave it like this, all it's going to do is just going to calculate 100 plus 90, which is 190, which is going to be incorrect. So what we need to do is we need to recursively call. So I need to call this one, I'm going to call it sum. Function is going to be called sum. And then I put sum like this, and then bam, we're done. We have our answer, which is which is um which is what I've highlighted. That's the answer. That's the answer to the recursive function. We are done solving it. So if you remember the steps, what's going to happen is it's going to start like this, right? Let's start at 100. So it's going to say 100 plus the sum of 100 minus 10, which is just the sum of 90, right? So this is basically the function sum when it's called with 100, right? This is what you get. And then the sum with 90 is going to be 90 plus the sum of the next term, which is 80. And then so on and so on until you reach negative 50. And then we back substitute, right? We go up the hierarchy and substitute the values and then eventually get to the final answer. Like we did here. That's why I said you should watch every part of the video, like we did here. We'll eventually get to that answer. So I'm pretty sure this is the formula because we've looked at it and we've solved it, we've calculated it, and yeah. Now we need to be certain that that's what answer to expect. Remember, when you're designed, right, you always have test data, inputs, outputs, variables, all those things, events, actions, all those things, so that you know what to expect when you run your program. So let me look at it. Say 100. Let me use my calculator on my phone to calculate what the final answer is. So plus 90 plus 80 plus 70 plus 60 plus 50 plus 40 plus 30 plus 20 plus 10 plus 0 plus, okay, it's no longer plus, it's minus 10 minus 20 minus 30 minus 40 minus 50. So we're expecting 400. So all of this up until minus 50, I can just say plus minus 50, this should give us 400. That's the answer that we expect. So keep that answer in mind when we solve this. So we have the recursive approach, right? So let's do that. So let's write the function. So sequence 1 recursive function. So let's define the function. And remember, we're working with integers here. There's no doubles here or strings. We're just working with integers. So remember, I said this function, I'm going to call it sum. And I want by value, meaning I just want the copy. I don't care about the original. And then it should return an integer. So as in, we have our function. we'll get to the base case. So I'm going to return, remember the formula is current n plus the sum of the next value. How do you get the next value? It's n minus 10, right? So return n plus sum n minus 10. But then if you leave it like this, remember, it's going to execute an infinite number of times and then your program is going to crash. I advise you not to even test it. You can test it in this scenario because it's easy. You can just quickly exit. In some programming environments or IDEs, okay, IDEs, it's easier. If you're running it on the terminal and you don't know how to exit, you're gonna face issues. Lucky enough, even the terminal allows you to exit, but then in some cases you just can't. So it's advisable not to even think about testing something that you know is going to run an infinite number of times or that you know is not going to stop running. So if we leave it like this, it's not going to stop running. We need to tell the computer what's the base case or what's the stopping point. I don't know, maybe there's another term, but then I picture the base case as that is like the stopping point. So if n is equals to, in this case, minus 50, right? When you reach minus 50, what should we return? We should just return minus 50 because there's nothing special about there's nothing special about it if you think about it. Look at it. What is there formula? It's not like this one. You see this one. Look at each term. You had to square each term. So that's why I left it like that. That's why I had that formula of that's why I said 1 times 1 instead of just saying return 1. I needed to show you where am I getting the 1 from because each term in this sequence, you have to multiply it with the term number. You have to multiply the term number by itself. So this one, it's just, yeah, it's just the number itself. There's just minus 50. There's nothing special about it. It's just return minus 50. And then I need to have an else. Remember in ComSci, this should be fine. This is gonna, even in Visual Basic, it's gonna work perfectly fine. But then because I don't want you guys to write something your lecturers didn't show you in the slides. So we're gonna use the else approach. Put else there. But then remember, you get marks for explaining. So you could just leave it outside and then not put the else and just tell them it's gonna run because this if statement is gonna check the if statement first, and then when it's done, there's a line outside the if statement, which is this return. So it's gonna still run. So this is going to be the recursive call, and then this is going to be the base case, right? Base case, recursive call. So let's call the function, right? So let me copy this comment here because I don't want to type too much. So recursive approach. And then this one, sequence 1, iterative approach. And then let's call the function, right? Remember, we need to pass 100 because that's the maximum, right? ATM n, I'm gonna call it n again. Remember, this parameter here, don't get confused. This parameter here, it only exists within this function. So I'm now in a different subroutine or button. So I can declare it as a local variable there. It's gonna work. That's what local mean. It means it's only for that local area. So okay, I need to say sum, then I need to pass in 100. And then obviously you need to print out the message. Oh no, what am I saying? I need to say answer. This is answer, right? And then I pass in 100 and then I'll put answer. We're expecting 400. Let's see if we did the right thing or we need to fix it. But then if you trust yourself, if you did the right thing, you should expect the right output. But then let's see. Oh, I think it's in the wrong button. I'm pressing the wrong button. We did recursive. I'm pressing iterative. Exactly. If you did the right thing, if you're confident in yourself, you get it the first try. You must be the GOAT. So that's 400. That's exactly what we expected. So yeah, recursion is not too bad. You need to just you see the first thing you need to really think about is this. Finding the formula. If you find the formula, you're done. You don't have to worry about the rest. You're done if you find the formula. So we have that. We are done. Let's go to iterative. So with iterative, we need to calculate the sum, right? So I need to declare the variable called sum or total. Some people prefer using the term total. This one, I can't say total. I can't put a one starting from one because if I start from one, it's always going to have an extra value of one, which my answer is always going to be incorrect. We don't want that. And then for n as integer, 1, 2, okay, not 1. It starts from 100 to -50. This is where the step keyword is very important. What's the step? If I say step 10, it's a problem because it's going to increment by 10, of which it will never get to this last point, which is -50. If I'm always increasing by 10, right? So I need to say -10. And then say next n. And then at the end of the day, I want to print the total. At the end of the day, I'm going to need to print the total. So yeah, let's calculate. So remember with the total, we need to say that total, we need to say the total, right? Remember it starts at 100. We need to say the total is just equals to total plus n. That's pretty much all there is to it. You see, iterative it's an easy approach. It's very easy because look at how straightforward this formula is compared to the recursive approach. The recursive approach was a bit complicated, and you really need to understand what's going on and all those things. Call the function within itself again. It's very cumbersome. But then with iterative, it's pretty straightforward. So it's gonna start at. Let me show you what's going on behind the scenes. It's gonna say total, right? What's the current value of total? It's 0 plus what's the current value of n? It's 100, which is 100. So therefore, the total has a value of 100. And then in the next step, and then in the next I step I use the step right. I change n by what? By subtracting 10. So n is now 90. But then what is total now? Total 100. So 100 plus what's current value of n? It's 90, which is equals to 190. And then and so forth until eventually I reach -50. So I expect it to work perfectly fine. So let's start and run the program. I think now we can test all four. So okay, we're doing iterative, right? Yeah. We're solving iterative. So let's test out iterative. Perfect. We have 400. And then recursive, we have 400. Perfect. Iterative, 14,400. Perfect. Recursive, 14,400. We have solved the problem. It was quite a journey, but then ended up getting to the final answer. So I will share the code, right? Just look at the description, when I upload the video, under the description section, you should find a link that sends you to a Google Drive where you're gonna see a folder and then you download that. I'm gonna zip it. It's gonna be a zip file. You download it and then unzip, and then you can run it on your Visual Studio and then tweak it and change it in whatever way you see fit. So for your practical, they were talking about using the keyword, the mod keyword. I don't think you guys are familiar with the mod keyword. So let me show you, let me explain the operators. Let's talk about operators in Visual Basic, right? By operators, I mean mathematical operators. Mathematical operators. So the way I like to view mathematical operators, you can think of them as like doctors, right? The person doing the operation is an operator, right? Who's the operator? We have the addition operator or the doctor who specializes in addition. And we have the subtraction operator or the operator or a doctor who specializes in subtraction and so forth, right? So let's see, we have addition, we have subtraction, we have multiplication, we have what else? We have division, right? But then this division is split up into two. We have integer division and floating point division or floating division. Let me just call it floating division, right? So what's the difference? With integer division, if you divide with the integer approach, you get back an integer. That's why you're calling it an integer division. Floating point, if you divide, you get back. Okay, so you guys are not familiar with floating point. Let me say double. If you divide, if you do the double division, you divide and then you get back a double. So it's maybe like 1.7. You get back a decimal. That's the difference. Integer division, you get back an integer. Double division, you get back a decimal. So we have this, and then we have one last thing, one last operator, which is the remainder operator or modulus operator. What does this one do? It returns or it gives you back. Let me not use advanced terms. It gives you back the remainder. So to make it simple, integer division gives you the quotient. Remainder or modulus operator gives you the remainder. Double division gives you both. Yeah, it gives you both. It gives you like a combination of both, right? That's the main thing. So how do we write these operators in Visual Basic? So the way we write it in Visual Basic, addition is simply plus, right? Let me just say it's simply plus. And then subtraction, simply a minus sign, right? And then multiplication is simply the asterisk, right? Or the star, the watashi wa star. And then we have division, but then let's divide them. Integer division, right? Integer division, right? The operator might seem weird, but then it's like this. It's like a backslash. This is what we call a backslash. And then the double division, I'm gonna call it double division, but that is the right term for it. It's a forward slash. Forward slash, right? You see, it's kind of like pointing forward, and then this is it's like it's leaning forward, and this is kind of like leaning backwards. So that's why we're calling it a backslash. This is leaning forward, so we're calling this a forward slash. And then we have the last one, which is the remainder or modulus, which gives you the remainder. What's this one? This one is the special case. Use the keyword mod, which comes from the word modulus. So they just only took those three letters. So just remember that. Comes, okay, let me just say these are the first three letters in modulus. So these are the different mathematical operators. So how do we test? Just give me a second. Let me save this. So how do we test? How do we? I'm sure you are familiar with all the other ones. You might not be familiar with integer division, but then let's see. I'm just one of these buttons, right? They're just gonna output something. Let's choose the sequence 1, right? Just to test these operators. Some of them, only 2, integer and modulus. So let's give an example, right? Let's say, what example can we use to demonstrate this thing? Example. It's a simple example. 3 divided by 2, right? You know 2 cannot go an equal number of times inside 3, right? Yeah, it's gonna give you a remainder of 1. So it also goes back to maths, right? There's this law, if you remember, in maths 1, right? 1A or 1B. Is it 1A? I think it's 1A. Or for those who are doing extended, it's 1A, 1E, 1A, 2E, and 1A, 3E combined. In one of them, they taught you this thing. How do you know if a number is odd? A number is odd, right? If and only if, right? 2k plus 1. That's when a number is odd. What is this 1? The 1 is the remainder. And what is k? Where, if you remember, it's there in your notes, where k, this E is an element, or it just means it belongs to that set. What set? The Z set or the integer set. K is an element of integer, or is an integer. That's what that's what an odd number means. It means it's any number that can be multiplied by 2 and it gives you a remainder of 1. Or 2 goes into that number even times, right, with no remainder. And then you have a 1 as the remainder, or you just simply add 1 to it. So let me make an example. For example, if I take 2 and then I have to multiply it by 2, right? K in this case, let's just say, um, um, assume k is equals to 2, right? Therefore, to find an odd number, I'll just say 2 times 2, right? Which is 4. It's going to be 4, right? But then I need to add the 1, which gives me a 5. Can 2 divide this number evenly or an even number of times? No, it can't. So that's where we are getting the plus 1. That's what the plus 1 just makes it just makes the number odd. But then if you leave it, if you leave it as multiplied by 2, it's going to be even. So you can also find out that the number is even when we have 2k, that's the formula, or 2k plus 0, the remainder is 0, where k is an element of z, right? And then I can make an example. Assume k is equals to any number, 10, right? So the answer is going to be 2 times k. K is what? 10. So therefore it's going to be 20 plus 0, which just gives me 20. So therefore this number is even. And then this one is going to be odd, is odd. So if you remember this thing in your maths class, if you don't, I'm sure you now know. So now we know when a number is odd and when a number is even. So we're going to use that to solve our problems, right? So let's say you're trying to find if a number is even, right? Let's say you ask the user, okay, dear user, can you enter a number? So let me do that first. Remember, your code is done sequentially, right? Remember those 3 blocks, building blocks in first semester in Informatics 1A. There's those 3 building blocks. There's sequential, there's I think it's iterative, it's iterative and repetitive. I forgot the other, the one of them. I think I'm correct, but I just forgot the. But then you remember those 3 building blocks. So what I'm going to do is I'm going to ask the user to enter a number, right? Enter a number, the user, right? So I'm going to say dim number, and then get that number from the user. And I'm gonna need to convert it to an integer at the end of the day. Because remember, the input box gives you back a string. So I need to cast it or convert it to an integer. So I'm gonna say enter a number. Simple as that. And then that number, I'm gonna store it inside the variable number. And then I'm gonna check if it's even or odd. Well, let's just say we're checking if it's odd. So how do I check that? I say if that number modded or, you see mod in a way it's like if I divide it by 2, what remainder do I get? Remember, modulus or finding a remainder, you still have to divide. But then you have to use the right keyword to tell it to give you only the remainder portion, not the quotient or not a double. So if I divide it by 2, because if you look at it, 2 is a very important factor in determining if the number is even or odd. See, 2k, 2, there's 2. So I need to divide it by 2 and see if, after dividing by 2, do I get a remainder of 1? After dividing by 2, if the remainder is equals to 1, right? That's what it means. If I divide by 2, remember modulus gives you the remainder. I can't do this. I can't say divide by 2. This will crash because it's gonna expect me to it's gonna return a double, and then I'm saying it's equals to an integer. But then let's say we're doing integer division, right? We're getting the quotient. If it's like this, it wouldn't give me the remainder, it would give me the quotient, right? So in order for me to get the remainder, I need to use modulus or mod to tell it, okay, mod this by 2 or divide this by 2 and give me the remainder. And then this equal sign, it says whatever is returned by this calculation, if it's 1, then I should do something, which is what tell the user that the number is odd. Number is odd. So let's test it out. I think I'll also upload these notes. I don't think they're necessary, but I'll just upload them. So let's enter a number. Let's start with 3 or 7, because 7 is odd, right? So let's say 7. It's going to check is 7 odd, even odd. Obvious, I'm expecting it to be odd. Exactly, the number is odd. And then whatever output we previously had. And then I run it again. Let's enter an even number, 2. I know the remainder of 2, if divide 2 by 2, the remainder is 0. So therefore, I'm expecting it to not do anything, because look at my code. Do I have an else? No, I don't have an else. So there's no case, or there's no part inside of my code that handles when the number is actually even. So nothing should happen, because this is going to be false. So it's just going to skip that if statement and then just quickly calculate this and output 400. So I won't get an output for this number. It won't tell me whether it's even or odd. There we go, as expected. But I know it's odd if nothing happened. I know it's even if nothing happened. So I hope that helps. Yeah, in simple terms, that's how you do it. So what I'm going to do is I'm just gonna comment this out and leave that and leave it there. If you wanna look at it, you can look at it, but then yeah. Okay, I think that's it for today. Let me check. Been an hour. Okay, and I know a lot of you guys are not gonna like that, but there's nothing I could do. I had to explain everything. So yeah, see you. I guess next week when you have to go through another practical. What I'm going to do, right? I've decided to come up with a simple formula. I'll do past practicals since now they've changed practicals. I'll do previous practicals or old practicals that are exactly the same as your new practicals. The only difference is that you guys are solving a different problem. Like here in this question, in this past practical, we're doing recursion, right? What is this practical that's due next week based on? It's based on recursion, right? So it's the same thing, because I can't literally just give you the answers. Yeah, I can't do that. That's unethical, and I'm sure it's illegal to some extent. I'm sure yeah, usually I would do something. So I can't do that. So I'm just gonna do past practicals. If you want me to do that practical after you've submitted and attended the prac session, then that's something we can talk about. But yeah, all the best with your practical.